Welcome, 7th graders, to your second day of lesson 9-4. Today you're going to use slope a little bit more, and our target is that I can calculate slope when given 2 points on a line. So things that you need to remember, starting on page 482, is that a point on a line is x, y. So your horizontal axis, then your vertical axis, and then the point that you are. And kind of always keep in mind, like if you're playing Battleship, you have a coordinate and you have to go a certain direction left and right and then up and down. Whereas slope, remember, is your rise over your run. Slope, day 2. An important thing you need to have written down is this slope formula. So remember first that if you're given 2 points, you're going to have your first point, which we're going to call x1, y1, okay? And you're going to have x2, y2. And your slope formula, remember, is the change in x, or the change in y over the change in x. If you remember from yesterday, we talked about it being the rise over the run. You have to remember that y affects your rise and x affects your run. So it makes sense that the change, and this should remind you of rate of change, it should be the change of y over the change of x when given 2 points. Make sure that you have that formula written down in your notes and you work on memorizing it. I also remember that I told you M stands for slope, and you can think of that as because slope is the steepness of a line, and it stands for, you can think M for move. The steepness shows you how much the line moves from one point to the next. So we're going to be able to find the slope using a table today. So given the 2 points, the points in the line are shown in the table, x and y. Okay, so all of these are ordered pairs of 112, we notice, 3-9, we notice, 5-6 is a point on the line, and 7-3 is a point on the line. Those are all ordered pairs, x, y. We notice that the change from a y coordinate to y coordinate is going down by 3, as our x coordinates are going up by 2 every time. So what you can do is choose 2 points from the table and find the changes in x and the changes in y. Notice this example chose 3-9 and 112 as the points. Notice we put our second point, our second y, and our first y in that order, and then the ordered pair that matches on the bottom. Little study tip on the side, you can choose any 2 points to calculate the slope. Whichever value of y you use, be sure you use the corresponding x. So for example, since I chose 9-3, notice that that ordered pair of 3-9 kind of just got rotated on its side, and it became 9/3. So it kind of just switches like that for y to be on top of x. Then you find the difference, so you do 9 minus 12 for a -3, 3 minus 2 for 2. That means that your slope is a -3,2. And you can check by graphing is always a good thing. So if I plot all those points, I have this line. And notice from one point to another, going left to right, of course, I go down 3 and over 2, down 3 over 2. So it makes sense that my slope is down 3 over 2, -3 over 2. So again, remember that this is my slope formula. We need this. These subscripts are read, x1 is read as x sub 1 and x sub 2, and vice versa. So x sub 1, y sub 1, x sub 2, y sub 2. So these are subscripts, that's why they're lower. Okay. Slope formula, again, is written below. And it says that the slope of a line passing through the points x1, y1, and x sub 2, y sub 2 is the ratio, we remember that word, a comparison of numbers, of the difference in the y coordinates to the difference in the x coordinates. Again, change in y over the change in x. X2 and x1 can't equal each other because then that would be 0. And you can't divide by 0. So that's just in the key concepts in words, in a model, and in symbols. So finding the slope using coordinates, and you need to get really used to this. You use it in 8th grade a lot and going forward. So we're going to find the slope of a line that passes through each point. So what I like to do is I always label. So this is my first x, first y, second x, second y. Always label them so you make sure you put them in correctly. Then I always write my formula, y2 minus y1 over x2 minus x1, and then I plug in them where they go. So I do y2, which is 2, minus y1, which is negative 4. You keep the negative. Over my x2, which is 2, minus my x1, which is a negative 1. Do those operations, and add the opposite on both of those, and I end up with 6 over 3, which simplifies to 2. So I should have a slope of 2. And I'm going to graph to check those points. I'm going to graph C. C is at a negative 1, negative 4, so I go negative 1 to the left and down 4. That's C. D was at 2, 2, so I go to the right, 2, up 2. Check my slope. How much? Make a line through them. I'm going to continue. It looks like I have to go up 6 over 3. Again, 6 over 3 is a slope of 2. So when you're going left to right, the line slants upward. This is correct because it's a positive slope. The line should be going up if we have a positive slope. Another example below, using these ones. So again, it doesn't matter which point you define as x1, y1. I usually just go left to right. This is my first point. This is my second point. Sometimes you may see that numbers maybe look easier, so you can make this your second point, first point, as long as you keep them together in that order. So for example, it says, let's use this as our first point and this is our second. So let's follow that this is true, that I can do that, not to confuse you, just to give you some options. So that'll work both ways. Maybe I'll try it both ways. So if they want this one to be x1, y1, and this to be x2, y2, because in the graph, that's how it looks. So then I do my formula. And I plug in for that formula. So the second y, I labeled that. So 2 minus, and my first y, 3, over my second x minus my first x. I'm going to chop minus, chop, chop. I get a negative 1 over 5. Then I check on the graph on the side. It looks like I have to go down 1 to the right 5, so that makes sense. Also makes sense since this graph is going downward, it's a negative slope. Say you wanted to do it the other way, to stick consistent with your x and y. Had I labeled this my first x and my first y, and the other one my second x and my second y, as long as you keep them together, it should work out. So say I did 3 minus 2 over negative 4 minus 1. Notice I still end up with 1 over negative 5. It's still negative 1/5 no matter what. Okay? But you have to keep them together. So you can check your progress on these 3, and then we'll do more with the table as well next time. So pause and try these and then come back and check them. I'm going to label all mine. Next, I'm going to even put my formula at the bottom just so I have it with me and I don't forget it in case I need to reference it. And I'm going to try it. My slope is, so y2, 3, y sub 1 is 2, x sub 2 is 5, x sub 1 is 2. 3 minus 2 is 1, 5 minus 2 is 3, and that's simplified for a slope of 1/3. You can graph and check as well. So x1, y1, x2, y2, plug them in. x sub 2 is negative 3, minus x sub 1 is 1, x sub 2 is 0, x sub 1 is negative 2. Notice I keep the negative, subtraction is part of the formula. Add the opposite, so I get a negative 4 up top and a 2 on the bottom. Negative 4 over 2 simplifies to 2. Slope of 2. But is it 2? Nope. Very careful, Miss Simmers. A negative over positive is a negative. Good checking myself there. Again, last one. We have x1, y1, x2, y2. Plug them into the formula. y2, y sub 2, minus y sub 1, negative 4, over x sub 1, negative 3, minus x sub 2 minus x sub 1. Add the opposite on all these. Integers are not going away, ladies and gentlemen. And then I have a positive 2 over a positive 4, which simplifies to 1 over 2 for a slope. Make sure you have the formula well versed and written down. Remember, slope is rise over run, y over x. Be diligent and careful with your negatives, as you saw that I almost made a mistake there. Rewatch the video if you need to. Examples in the book, personal tutors online, any other source that is going to give you correct and accurate and helpful information. Bring your notes to class. Do your best.